Welcome to this lecture of numerical analysis. In this lecture, we will study the four-stage explicit Runge-Kutta method for solving an initial value problem. Previously, we have studied Euler's methods, which were named as Euler methods. Then we have also studied the Cauchy-Euler method and the modified Cauchy-Euler method. Now we have a similar method for solving the initial value problems that we call the four-stage explicit Runge-Kutta method. So we begin with an initial value problem like this: y dash equal to f of xy with y of x naught equal to y naught. And again, we assume we have a step length h here. Then the nth approximation to the solution is given by yn plus 1 is equal to yn plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. Now since we are using four unknown quantities here, k1, k2, k3 and k4, because of these four different numbers, we are calling this method as the four-stage explicit Runge-Kutta method. Now here we have the values for this k1. K1 is defined as h f of x and yn, and there was a similar definition of this k1 when we have studied the Euler's three methods. And similarly, we have defined k2 here as h f of xn plus h by 2, yn plus k1 by 2. So the second coordinate of k2 uses k1. Next, k3 is equal to h f of xn plus h by 2, yn plus k2 by 2. So again here second coordinate of k3 uses k2 now. And finally k4, it is defined as h f of xn plus h, yn plus k3, where from this yn plus 1 up to this values of ki's, this n is greater or equal to 0. So this is the basic definition of four-stage explicit Runge-Kutta method. Now let's come to our exercise. Find the solution of this initial value problem on the interval 0 to 0.4 using the value of h as 0.2 and f of xy is minus 2xy squared. So let's come to the solution. So first we write down what we are given. Given f of xy is equal to minus 2xy squared. Now y of 0 is equal to 1 means we are given x naught is equal to 0, we are given y naught is equal to 1, and we are given h is equal to 0.2. Now let's first compute the values of x1, x2, x3. So now, as also earlier used in the Euler's methods, we define this xn as xn minus 1 plus h, where n is greater than or equal to 1. So that is x1 is equal to x naught plus h, but x naught is equal to 0, h is equal to 0.2, so that means x1 is equal to 0.2, x2, that is x1 plus h, so this is equal to 0.2 plus 0.2, which is equal to 0.4, and 0.4 is the right end of our given interval 0 to 0.4. That means actually we are asked to find y of 0.4. So thus what we are required to find, thus we are asked to find y of 0.4. Now y of 0.4 is calculated here. This is actually the value of y of x2, which we denote by y2 in our definition of Runge-Kutta method. So that's we are asked to find the value of y of 2. We know that now we have the formula from Runge-Kutta method. It is yn plus 1. It is equal to yn plus 1 divided by 6 k1 plus 2k2 plus 2k3 plus k4. Where this k1, k2, k3 and k4 are defined here for n equal to 0, we obtain the value of y1. We obtain y1 is equal to y naught plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. Now we shall calculate these ki's one by one, where k1, now using n equal to 0 here in this formula, we get k1 equal to h f of x naught y naught, which is equal to 0.2 into f of x naught is 0 and y naught is 1. This becomes finally 0. Or we shall properly calculate it. This is equal to 0.2 into minus 2 into x, that is 0, into y, that is 1 squared. So this is equal to 0. K2 is equal to h f of x naught plus h by 2 y naught plus k1 by 2. So this is equal to h f of now 0 plus 0.2 divided by 2 comma 1 plus 0 divided by 2. Now calculating these numbers, we finally arrive at 0h f of 0.1 comma 1. Now this is equal to 0.2 into minus 2, which is f of xy is minus 2xy square. Now x is equal to 0.1 into 1 square. This is equal to minus 0.004. So that is the value for k2 here. Now similarly we can calculate k3. K3 is equal to h f of x naught plus h by 2 y naught plus k2 by 2. Now using the value, this is equal to h f of 0.1 comma 1 minus 0.004 divided by 2. So this becomes h f of 0.1 comma 0.998. Now substituting the value of the function f of xy equal to minus 2xy square, this becomes 0.2 into minus 2 into 0.1 into 0.998 whole square. Now multiplying all these numbers, this becomes minus 0.0398. Similarly, we can calculate k4. By definition, it is equal to f of x naught plus h y naught plus k3. So this becomes h f of 0 plus 0.2 y naught is y1 minus 0.30398. So this is equal to h f of 0.2 comma 0.9601. Now using the function f of xy, this becomes 0.2 into minus 2, 0.2 again x, then 0.9601 whole square. Now multiplying these numbers, this becomes 0.0737. In fact, negative. So therefore we have computed the values of all ki's. So hence let's call that equation as, okay, this equation now number 1. Hence from equation 1 we have, now equation 1 is our equation where we have used the value of n as 0 to find this, calculate this y1. So therefore our y1 is equal to, substituting the values of this is equal to y naught plus 1 divided by 6 k1 plus 2k2 plus 2k3 plus k4. So now y naught is equal to 1 plus 1 by 6. Now k1 was 0 minus 2 times 0.004 minus 2 times 0.0398 minus 0.0737. Now adding up all these numbers, we finally get the answer as 0.1.0268. So actually this is y1, and y1 as we call y of x1, and x1 was equal to 0.2, so that's actually the value of y of 0.2. But we are required to find the value of y of 0.4. So next, now in the given formula for yn plus 1, we put n equal to 1 and we get y2 as y1 plus 1 divided by 6 k1 plus 2k2 plus 2k3 plus k4. Let's call this as equation number 2, where we again have now recompute these ki's, where now k1, that's equal to h f of x1 y1. Why it is f of x1 y1 now? Because here in the formula for the Runge method, when we put n equal to 1, we get y2 equal to y1 plus 1 by 2 ki's, and k1, put n equal to 1 here, we get k1 as h f of x1 y1. So therefore now this becomes equal to, similarly as calculated in the previous step, this is equal to h f of, now x1 is equal to 0.2 and y1 as calculated, this is 0.1.0268. Now substituting the functional value, this finally get 0.0843. Similarly k2, by definition this is equal to h f of x1 plus h by 2 y1 plus k1 by 2. So this becomes h f of, now x1 plus h by 2, that is 0.2 plus 0.2 divided by 2, then 1 minus, y naught is equal to 1, y1 is equal to 1.0268, then minus k1, that is equal to 0.0843 divided by 2. Now calculating these numbers, we get h f of 0.3, 0.9864. 9864. Now using the function f of xy, this becomes 0.1167. Now on similar lines, we can have k3 as h f of x1 plus h by 2 y1 plus k2 by 2. So this becomes h f of 0.3. Now y1 is 1.0268, then minus 0.1167 divided by 2. Now calculating all these, we get h f of 0.3, 0.9684. Now using the function f of x by this finally becomes 0.1125. Now similarly, k4, which we now defined as f of x1 plus h, y1 plus k3. Now this is equal to h, f of 0.4, and the second coordinate is 0.9142. This is equal to minus 0.1337 using the function f of x and y. So hence from equation y2, which is now defined as y1 plus 1 divided by 6, k1 plus 2k2 plus 2k3 plus k4. This is now equal to y1 is equal to 1.0268 plus 1 divided by 2. Now our new k1 is equal to 0.0843 minus 2 times 0.1167 minus 2 times 0.1125 minus 0.1337. Now adding up all these numbers, we finally get 1.1395, which is actually the value of y2 on the left hand side and y of 0.4. So that is y of 0.4 is equal to this thing.